Alright. Alright, good morning everybody. How are you guys doing today?
Good morning, sir.
Sir, I'm retired.
I know that. Totally. Alright, good morning everybody. How are you guys doing today? Wait a minute. Isaac, did you just read my lips? Because I was muted, so how do you know I said good morning?
No, I said good morning because I wanted to say good morning.
Okay, gotcha. Alright, so how is the group work coming along? The work, okay, there was one person I saw finish the work and they weren't in a group, so that person got 0. Alright? Because I said it was, I'm just kidding. You got your marks. But for those who haven't started yet, remember you have until Friday and you should be in our group. Alright? To help you to understand the content. Now, there were 2 questions. Have you guys started? Have you met in a group as yet?
Yes, sir.
Alright? Any
So I wanted
concerns?
to ask something like, where do we research the questions?
Alright, this lovely book here. Alright? Mine is a little bit torn. But this book gives you really great examples and it really guides you in terms of answering that research question. On page 30 to 38. Alright?
Wait, sir. The triangles weren't too small, right?
It was a bit too small, but as long as you stated your scale, I didn't have a problem with it.
Alright, sir.
Alright? So let's begin. Alright, we're gonna continue from where we left off. Alright, so the technical drawing. And today we're gonna go over reduction and enlargement. Everybody's favorite topic. Reduction.
Wait, sir, weren't we going through another one? Like a path of a circle and another circle? That was unfinished?
We can repeat that?
We were, like 2 classes before this, we were going through a path of a circle on another circle.
Oh, right. You're so correct. My bad. That was the Epicycloid, right?
Right, yeah.
Right. Okay. So I just realized not everybody got the topic, so let me just continue from there. My bad. Alright? Because we had a little issue with finishing up in that one session. So let's continue from there. So let me quickly sketch where we left off. So go for that paper for me, where we left off, and I'm just gonna sketch where we left off. Wow, everybody's camera is off. I guess mine should be off too. I'll wait until you guys are here, because I see nobody in the waiting room or the class.
Sir, I think your Wi-Fi is a bit slow because some of our cameras are on.
Alright, I see Jada Lee, cameras off, Harshita, Cameron, and Isaac. Yeah, there we go. 2 more.
Sir, mine was on.
Yeah, yours is on. Jada Lee and Cameron. Alright, Jada Lee. Alright, I'm just gonna place her in the waiting room until she's back. Okay, so let's continue. We're gonna quickly continue from the Epicycloid. It was spelled Epicycloid, and we said that picture you. That's another perfect circle. Wow, give me a round of applause. Picture you walking, right? And you are riding a bicycle up a hill. The path of the bicycle would form a curve. Everybody remember that? And we call this curve a loci. And the name of this loci is epicycloid. Because the epicycloid is where you have a circle that circumnavigates the peripheral or the circumference of another circle. So if you were riding a bicycle up a hill, the path of the wheel would be as such. Everybody understand?
Hey, sir, this is what we were doing.
Yes, but let me show you where we stopped off. So let me just quickly sketch. I said that you should have had your base, right? Your angle of 120 degrees. Everybody remember this? Hello? Do you guys know this part? So you should have had your base right here. Then your smaller circle. About this here. Here's my center point. And then I will draw a larger circle. Alright. Did everybody reach this point? We said the next step was to label this circle into 8 points. 1, 2. So we have 1 going down, 2 going across, 3 going down. Right. Did everybody finish here?
This is what we were doing last week?
2 classes ago. The Epicycloid.
Oh.
Yeah. So go for that paper for me. We stopped here. So this was last week Friday. Alright? I said that you should have used this point now. Open your compass to the point of 0 to, let's label it here. In what direction do we label? Clockwise or anti-clockwise?
Anti-clockwise.
Right. So let's say my point P is here. That means this is going to be 1, this is going to be 2, 3, 4, 5, 6, 7. 1 second. My point P is a little bit off. So my point P is here. We have 1, 2, 3, 4, 5, 6, 7. And P would make my 8th point. Let me take a picture of it and put it in the group so you can follow along. Did everybody reach this step? Senior 3.
Yes, sir.
Alright, so we're going to continue from here.
Wait, weren't we at the division of the bigger?
Yes, that's where we're at now. So let's do that quickly. I said you're going to open your compass. Alright? Open the width. So if you made your drawing a little bit too large, you could have scaled it down to half the size. But you're going to open your compass using this point O. Let's label it O. Alright? Open to the width of O to 1. And you're going to draw your curve, and it passes through 7 as well. Alright, from O to 1, draw your curve, it passes through 7. Alright? Open your compass, O to 2, it passes through 6. Open your compass, O to 3, it passes through 5. O to 5. Passes through 3, and then finally you have O to 4 by itself. Everybody recall that now?
Yes, but your 4 might be my 6 in my drawing.
Wait, see, my 4 would be your 6 because you labeled it otherwise. That's fine. Because you can just relabel it. So P would be your first point at the base, then 1 would be directly to the right, and then continue to number around. Just the same. Alright?
There are just more numbers than there are
Can you repeat that for me?
like more cuts in my circle. Well, there are more cuts in the circle than
Okay, there are more cuts in the circle than you have points.
it's the yeah.
Yeah, right. But here's the thing. You're gonna now draw a final cut on your circle from your center point. Alright? So I want you to open your compass from O, go to your center point, and you're going to draw dotted lines from your center point. Let me take a picture of it and show you in the group. So look in the group for me. Once everybody's at this stage, I'm gonna just quickly play a short little video to explain the next steps if my drawing on the board is not 100% perfect. And second, alright, let's begin now. Let me just quickly screen share for you. Here we go.
If you're losing money as a trader, here's why. Emotion. That's the problem. See, Paul Tudor Jones is one of the great.
Let us understand the construction of Epicycloid. Draw locus of a point P on the periphery of a circle, which rolls on
One second, let me pause this. I'm turning on my camera. Let's put it side by side. There we go. So I can still sketch on the board for you. There we go. There we go. Excellent. Alright, let's continue. Can anybody hear the video?
For one revolution, it will cover pi d distance on arc.
I think it might be a little bit low. So let me just... No thanks. There we go.
It will be decided by included arc angle theta. Calculate theta by formula. Theta equals rate.
What do we say the small arc is again? The rolling circle or the base circle? Shirag. Small arc is the rolling circle or the base circle?
Smaller is the rolling circle.
Right. We call the base circle the directing circle because that determines the motion of the rolling circle. Alright? So you have the base circle or the directing circle and the R, small r, which is the rolling circle.
Step 1. Now divide the circle into 12 equal parts and also arc PQ in 12 equal parts.
Alright. This is where we stopped last class. We divided this curve into 12 parts. Alright? And I said that you should use a method of the protractor, right? Find out how many degrees makes one division. How much did you find a degree to be? Harshita.
Yes, sir.
Right? If I have 120 degrees and I want to divide this line into 8 parts, what's 120 divided by 8?
120 divided by 8.
Yeah.
15.
Wait, you're very low. Can you repeat that for me?
15.
15, right. So what you're going to do, you're going to use your protractor. From here, you're going to measure 15 degrees each time. So when 15 degrees is marked off, line it up and then draw a line straight back to the base. When 15 degrees is lined up, mark it here, draw it straight back to the base. Do the same steps until you have the 8 partitions for your drawing. Everybody understand that?
Yes, sir.
There we go. Alright, let me just quickly zoom in for you. So there's my 8 divisions. Alright? You should follow the same. Remember, this is a sketch. As soon as we get physical class again, I'll be able to just draw it actual professionally. Alright? Let's continue now. Alright, so is everybody finished with drawing the 15 degrees? Can I continue?
Yes, sir.
Alright, now here's what you're going to do. This is the beauty of TD. You're going to use your ruler, right? Copy the angle that you have here, and you're going to extend this line to touch the very top of the drawing. Just like that. Copy this angle and extend that line to the very top. Copy this angle and extend it, extend it, extend it, extend, extend, and extend. Alright? Now once you've done that, let me take a picture for you so you can see what I'm saying. It's something very critical that you must do next. When you extend each line, the point to which it touches the center line, you're going to call that center points. Alright? So we're going to call this our very first center point. Alright? But let me just quickly show you how it looks on the screen here.
Name the given points as shown. Step 6. Extend line O1' and O2', focus line at C2, C3.
There we go. So we're going to call the base circle our very first center point C. Right? And then the point to which this touches to make our very first division 1, we're going to call C1, which means center point 1. Where this touches 2, we're going to call this C2, which means our center point 2. C3, 3, C4, 4, C5, 5, C6, 6, C7, C7, 7, and C8, 8. But let me take a picture for you. Any questions about that? Here you go. Alright, look at the picture in the chat for me. Everybody at the stage?
Yes, sir.
Alright.
C3, C4 till C12. Step 7. From points 1.
Right. So we've done this point already where we draw the lines throughout.
2, 3, 4, 5, 6 on the circle. Draw arc through each point specified. Step 8. Take.
Right. Here's the beauty of it now. He's gonna draw arcs. I want you to draw circles. Alright? So what you're gonna do? The very first step. What was the diameter of this small rolling circle? Quickly remind me. What's the diameter? Anybody? Let me call on someone. 25 millimeter is the diameter, or 25 millimeter is the radius?
Radius.
Right. So, using this radius, I'm going to go to C1 and I'm going to draw that very same circle. Alright? Going to C1 with a radius of 25 and I'm going to draw that very same circle. But yours should be in construction line. Very, very thin. Alright? Make it very, very thin for me, please. Right? Once you draw that circle for me.
Sir, would C1 be the center point?
Yes, C1 would be your first center point. Right? This was technically C0. This is C1. So at C1, you're going to draw the second circle, or the first circle that you're going to draw from the rolling circle. And what this means is that you're basically simulating the path of the bicycle wheel. Alright? 1 second, I'm going to just quickly show you.
Taking C1 as the center and radius equal to 25 mm, draw.
Right. Okay? So let me highlight for you now where exactly that is. You see wherever C1, right? Wherever C1 touches the first point, which is right here, that's going to be P1. It's going to be P1. Let me take a picture for you. Everybody stop what you're doing and look on the picture in the group. Check it for me. It's loading, it's loading. The Wi-Fi connection is slow. Alright, give it a moment. It's very important that you understand what the second circle actually means. Alright, can everybody see the sketch?
Yes, sir.
Alright, now think about it. If I am driving a bicycle, right, at one moment in time, the wheel would be at one point, and then another moment in time, the wheel would move some distance further, right? So each time I'm driving the bicycle, there are multiple center points that the wheel has as it's moving along. Everybody see that?
Yes, sir.
Let me quickly get a GIF, as you could call it. Epicycloid. Epicycloid GIF. Let me explain with a diagram. It's always good to have diagrams. So Jada Lee, are you hearing me? Jada Lee, are you there? One second. Yes, can you hear me, Jada Lee? I always ask persons randomly just to verify that you're here. So picture this as your bicycle wheel as it's driving along a hill, right? Every time it moves some distance, doesn't it have a new center point? Everybody see that? So its center point was here, then it moved to here, then it moved to here. So this could have, for example, 30 different center points because it's moving in space and time. Understand that? So in regards to this one now, on the sketch, you see that I drew a second circle. That means that's the wheel in some distance away. Alright? And the point to where it touches the very first curve that we drew from 7 to 1, that's going to be P1 wherever it interacts with that line. Everybody got that? You guys are very quiet today. Very, very quiet. It's making me uncomfortable. Alright, 1 second. Christoph, Bulgin, Talia, Sanjana. Can you understand me? Let me continue because I'm hearing Sharad participating. So, the next one. We're at center point 2. Using the same radius of 25, I'm going to draw my second circle very faintly. Very faintly. Alright, it should be in construction lines. So let's draw the second circle. And there I go. Alright? Now wherever this second circle touches the second curve, let me play that video for you.
Draw an arc cutting the arc through 1. Now taking center as C2. Draw an.
So this was the first curve and this is the second curve. So wherever the second circle touches the second curve, you're going to identify that line and call it P2. Let's do that. So here's the second curve right here. That's P2. We're going to call it P2. Let's continue. Where would my third circle point go? Identify it by calling it its name. Shrug. Where would I place my third circle? What point would I place it?
C3.
C3, excellent. So I'm going to go at C3, open the 25 and draw my circle. There I go. And wherever it cuts the third curve, which is going to be this one now.
Now taking center at C3, draw an arc through 3.
Right? Wherever it touches the third curve, I'm going to identify a point as my P3. Here we go. Right here. 1 second. Right here. That's P3. And P4 now. P4. That's the final point at the very top. Because for it to be a curve, there must be one part going up and then one part going down. So P4 is going to be the highest point.
3. Similarly, mark points from centers.
Alright, so because this person used 12 points, I'm going to pause the video there and I'm going to stop the screen share so you can look back on the screen here. That rhymed so much, I fear. Okay, let me just put the camera up. Can everybody see that? So we have P1, P2, P3, and let's draw P4 now. Let's draw P4. Where would my fourth center point be? This question goes to